Okay, measures of dispersion. Well, measures of dispersion are used to describe the spread of data items that we have in a data set. Well, the most common measures of dispersion are the range and the standard deviation. So, we're gonna talk about this too in this chapter. So, range is the highest data value minus the lowest data value that we have. So the difference between the highest and the lowest data values that we have in a data set gives you the range. For example, if I tell you that the Calgary's hottest annual temperature is 28 degrees and its coldest annual temperature is minus 30 degrees, then the range in temperature is the highest one, 28, minus the lowest one, which is negative 30, right? So we get 58 degrees. So 58 degrees is the range. Well, in the range, as you see, we just consider the highest data value and the lowest data value. So it's more common to use standard deviation, okay? Because standard deviation actually considers all the data items that we have. So what we do, we want to see how far each data item is from the mean value. How much each data item differs from the mean value, okay? So, um, let's just explain, how we come up with an equation for the standard deviation. So, we want to see how far each data item is from the mean value. So, first of all, I find the mean value. So, I find the difference between each data item and the mean value, and because I don't want to have a negative value, so I make that data squared. That's data item minus mean value, I make that squared. Well, I want to consider all data items, so I add them. I add the results, and because I add them, then I divide it by n minus 1. N is the number of data items that we have. Because I had a squared, I made the difference squared, so I take a square root. And so here is the equation that I have for the standard deviation. So sigma x minus mean value squared over n minus 1. So here, as you see, I have used the absolute value because I want to have a positive value, but doesn't matter. Even if you don't take the absolute value because you make the square, that's fine. If you have a negative value when you make the square, it's positive. So it's fine if you write down standard deviation is the square root of sigma x minus mean value squared over n minus 1. That's right too. So that's fine. Okay, well, let's go back to the example that we had, right? So, the speed limit for some, selected countries. Let's say I want to find the standard deviation for the speed limits. Okay, I have a set of data, speed limits. I want to find the standard deviation for the speed limits. Okay, so I need the mean value. Okay, so these are the data items that I have, the speed limit. So I create a column for that. Well, what I do, I find the mean value. So to find the mean value, we add all the items and then we divide it by the number of items that we have. So mean value then is the sum of all the data items. So 55 plus 55 plus 55 plus 70 plus 55 added to 60 added to 55. Next one is 65 plus 60 plus 75. 1 2 3 4 5 6 7 8 9 10. I have 10 data items, so divided by 10, so it gives me the mean value. Okay, so then I find the difference between each item and the mean value. Okay, so here we go. So the mean value is 60.5. So when you calculate the mean value is 60.5, then I find the difference between each item and the mean value. Okay, so the difference between 55 and 60.5, you find it, okay, that's 5.5. I put the absolute value. If you get a negative value, that doesn't matter. You can put negative, or you can just get rid of the negative, because then when when you make it a squared in the next column, so negative times negative is positive, right? Okay, so each item minus mean value, okay, is presented in this column. And then whatever you have in this column, next column you make the squared. So 5.5 squared is 30.25, and so on, keep going. When we have x minus mean value squared, then you add them all. You have a sigma in your equation. So you add all the values that you have in this column. I added all these values and I got 472.5. Okay, so standard deviation is square root of, okay, so numerator is 472.5, denominator is n minus 1, n is 10, right? So I have 10 data items, 10 minus 1 is 9, right? So guys, don't forget 472.5 divided by 9, and then don't forget to take the square root, okay? That's really important. Well, when you do that, you get 7.25, that's standard deviation, okay? So here we go. When a standard deviation is smaller, it means that more data items are closer to the mean value. When a standard deviation is higher, it means that more data items in your set are far from the mean value, okay? So we have an example to show what it means here. We have 4 sets, A, B, C, and D. As you see, all data items in set A are 4, mean value is 4, so standard deviation is 0. Here we go. So when a standard deviation is smaller, it means less data items are far from mean value. When standard deviation is bigger, you have more data items, far from, that have values far from the mean value, okay? So here we go. For example, part B, standard deviation is 0.8, then part C is 1, part D is 3, right? As you see. So look at the values that we have, how different they are from, the mean value, okay? So we have a bigger standard deviation, part D. Here we go. So what is normal distribution? Well, the data items, they tend to cluster around the mean value, okay? Well, the more an item differs from the mean value, the less likely it is to happen, okay? For example, let's say we have a researcher that selects a random sample of 100 men, adult men, and the researcher wants to measure their heights and creates a histogram for the data. As you see, for example, we have figure A, B, C, and D that they show the sample size, is increasing. From A to D, the sample size is increasing, right? Well, as you see in part C, when the sample size is increasing, right, from A to C, look at C, we can see that we have a symmetric shape. When the sample size increases, so the graph symmetry actually increases too. Look at from A to C. When the sample size is increasing, the graph becomes more symmetric, right? If it were possible to actually include all adult males in our research study, the entire population, I mean, then the histogram would approach what we call that the normal distribution. That's what you see in part D, right? So this distribution is also called the bell curve because it has a bell shape, right? Or we call that Gaussian distribution, okay? So it's really, really symmetric as you see, right? So that's what we actually call normal distribution. Well, let's say we have a normal distribution, right? So The shape of the normal distribution depends on the mean value and the standard deviation, so it's completely symmetric. The mean value is right in the middle. When a standard deviation is bigger, okay, well, it's like, the distribution becomes more dispersed, right? So it's like the red graph that you see here, so standard deviation is actually bigger here. Okay, when a standard deviation is smaller, well, your symmetric bell-shaped graph becomes thin, just like what you see here, right? So standard deviation here is smaller. So when standard deviation is smaller, your symmetric bell-shaped graph is thinner. So it's gonna spread out when a standard deviation is bigger, right? But as you see, the mean value is right in the middle. In normal distribution, we have a symmetric shape. So I'm gonna use this normal distribution and this symmetric shape to actually solve problems. Well, I'm gonna use the rule that we call it 68, 95, 99.7 rule for the normal distribution to answer some questions. Well, what does it say? Let's say we have, a normal distribution, so the mean value is right in the middle, okay? Guys, if I go one standard deviation to the right and I go one standard deviation to the left from the mean value, that area of my graph, okay, actually, as you see here, approximately 68% of the data items, they fall in that area. They fall within one standard deviation away from the mean value, okay? So, what about second one, 95? Okay, now, if I go two standard deviations to the right from the mean value, and I go two standard deviations to the left from the mean value, okay, that area actually almost 95% of the data items, they fall in this area, okay? Two standard deviations away from the mean value, both directions, okay? Now, 99.7, okay? If I go three standard deviations to the right and I go three standard deviations to the left from the mean value, okay, that area, look at that, almost 99.7% of the data items, they fall in that area. Okay, so I can use this rule to answer some questions. Let's see. Male adult heights in North America are approximately normally distributed. The mean value is 70. Okay, mean value is 70 and the standard deviation, it says, is 4 inches. Find the height which is two standard deviation above the mean. Okay, mean value is 70, so two standard deviations higher, so I added to 2 times standard deviation, which is 4. So 2 times 4 is 8 plus 70, 78. Okay, that's the height we are looking for. Part B, 3 standard deviations below the mean. Okay, mean value is 70 below minus how many? 3 standard deviation. 3 times 4 standard deviation is 4. So 70 minus 12 is 58. Here we go. So look at here. 2 standard deviations above the mean, so the mean value is right in the middle, 72 standard deviation to the right, yeah, as you see 78, 3 standard deviations below the mean, 1, 2, 3, as you see is 58, right? So here we go. Now, this question says, use the distribution graph to find the percentage of men with heights between 66 inches and 74 inches. Okay, first of all, this question told us that mean value is 70 inches and a standard deviation is 4. Okay. It wants you to find the percentage of men with heights between 66 and 74 inches. Okay. So, if I have a graph and mean value is 70, one standard deviation to the right is 74 because standard deviation is 4. And one standard deviation to the left, 70 minus 4, 70 mean value minus 4 standard deviation is 66. Well, we have a graph normally distributed. It says find the percentage of men that have heights between 66 and 74. So 66 and 74, one standard deviation away from the mean value. So how many percent of the data items approximately fall in that area? Well, the rule says 68%, right? Here we go. This area, 68%. So the answer is 68%. What about part B? It says between 70 and 74. Okay, guys, if you look at the graph that we just covered, okay, from 60 to 74, we have 68%. And we have symmetric shape, right? Now part B says between 70 and 74. It's asking about this area, 70 to 74. Okay, here. What about that part here? It's talking about that. Well, it's half of 68, so 68 divided by 2 is 34%. Now it says above 78, part C, above 78. Okay, just look at the graph. 78 is 2 standard deviations to the right. Okay. If I have the graph, the mean value is 70. One standard deviation to the right is 74. Another one is 78. So 70 is the mean. One standard deviation to the left is 66. Another one, 66 minus 4 is 62. Okay. They have a symmetric shape. Here we go. 78. 1, 2, 2 standard deviation to the right. So 2 standard deviation to the left. So guys, we know that based on the rule, 95% of the data items, they fall between 62 and 78. But now it wants you to find above 78. So 95% they fall between 62 and 78. So I subtract that from 100. 100 minus 95 is 5%. It means 5% they fall above 78 and lower than 62. So 5% of data items are above 78 and below 62. What does the question ask? It says above 78. You don't want it lower than 62. We have a symmetric shape, so I divide it by 2. 5 divided by 2 is 2.5%. So the answer is 2.5%. So as you see, part A is 68%, part B 34%, and part C 2.5%. Well, look at this question again. I want you to look at the slide. So look at the graph. Just draw a graph separately for each part. Okay, look at the percentage and find the percentages yourself. Okay, and then compare your results with these results. Okay. So, IQ tests are normally distributed. The mean value is 100. Okay, mean value is 100 and the standard deviation is 16. It says in part A to D, use 68, 95, 99.7% rule to find the percentage of people with these IQs. Okay, first one, A, between 68 and 132. Okay, I draw a graph. Mean value is 100. One standard deviation to the right is Okay, 100 plus 16 is 116. Add another one plus another 16 is 132. Okay, 100. Okay, now to the left, minus the standard deviation, minus 16. Use your calculator. 100 minus 16 is 84. Okay, subtract another 16. Minus 16 is actually 68. Now we have two standard deviations to the right, two standard deviations to the left of the mean value. So part A wants you to find the percentage between 68, okay, and 132, this area. Based on the rule, two standard deviations to the right, two standard deviations to the left. What percentage of the data items are approximately in that area? Yeah, right. How many? Okay, two standard deviations away from the mean value, 95%. Now part B. What about between 68 and 100? Okay. 100 is the mean value right in the middle, right? So guys, as you see, we saw that, I'm just copying the graph that we have in part A. We saw that 95% of data items are between 95% or between 68 and 132. What about between 68 and 100? Well, we have a symmetric shape, right? Well, we are just talking about half of the data, right? Half of that. So just 95 divided by 2, right? Just divided by 2. 95 divided by 2 is 47.5. 47.5%. Part D, it says above 116. Okay, 116. Guys, 116 is one standard deviation higher than the mean value. Okay, so let's see. If this is our graph, here is 100. 116 is one standard deviation to the right. So one standard deviation to the left, 100 minus 16 is 84. So between 84 and 116, we have 68%. So between 84 and 116, we have 68%. We want higher than 116. So I subtract that from 100. So 100 minus 68 is, use your calculator, 100 minus 68 is 32. So it means we have 32% lower than 84 and higher than 116. The question was just higher than 116, doesn't want lower than 84. We have a symmetric shape, so I divided by 2, right? So 32 divided by 2, it just wants higher than 116. 32 divided by 2 is 16, so we have 16% above 116. So here is the answer, 16%. What about lower than 68? Okay, lower than 68. So lower than 68, I draw the graph again. Mean value is here, right in the middle, 100. One standard deviation higher is 116. One more is 132. One lower is 84. 84 minus 16 is 68. Here is our graph. So 100 is in the middle. Okay, so we want lower than 68. Lower than 68. So we know that we know that 95% are between 68 and 132. So between 68 and 132, we have 95%. You want lower than 68, below 68. So I subtract that from 100. 100 minus 95 is 5%. So it's like I have 5% lower than 68 and higher than 132. What do you want? You just want below 68. You don't want higher than 132. We have a symmetric shape, so I divided by 2. 5 divided by 2 is 2.5%. So 2.5% below 68 here. 2.5% is the answer. Well, answer this question yourself, and yeah, just compare your results with my results. Okay, so sorry, here we go. So here are the answers if you want to compare. 95, 47.5, 16%, and 2.5%. Okay, so I'm gonna stop here, and then we're gonna talk about the z-scores.